Hello, my dear students. Today in this class, we will discuss some numerical problems related to inverse linear functions. So, exercise 2.2. So, let's start. Exercise 2.2, question number 3. Prove that tan inverse 2 by 11, tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. Prove that tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. Solved. Left hand side is equal to tan inverse 2 by 11 plus tan inverse 7 by 24. We know that tan inverse x plus tan inverse y is equal to tan inverse x plus y comma tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. Therefore, we can write tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse x plus y. Therefore, x is equal to 2 by 11 plus y is equal to 7 by 24 divided by 1 minus xy. X is equal to 2 by 11 into 7 by 24 is equal to tan inverse 11 into 24 4 2 4 2 4 6 264 24 into 2 4 to the 8 2 to the 4 plus 77 divided by 264 minus 14. This equal to tan inverse 264 8 plus 7 15 7 plus 4 11 plus 1 12 divided by 4 minus 4 0 6 minus 1 5 is 2. This equal to tan inverse 125 divided by 264 into 264 divided by 250. 264 is equal to tan inverse 1 by 2 is equal to right hand side. Therefore, hence proof left hand side equal to right hand side. That is tan inverse 2 by 11 equal plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. Next, we will discuss question number 4. Tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 by 70. Solution: left hand side is equal to tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to, we know that 2 tan inverse x, already we have learned 2 tan inverse x is equal to tan inverse 2x divided by 1 minus x square. Already we have learned in previous class 2 tan inverse x equal to tan inverse 2x divided by 1 minus x square. Therefore, this is equal to tan inverse 2x 2 into 1 by 2 divided by 1 minus 1 by 2 whole square plus tan inverse 1 by 7. This is equal to tan inverse 1 divided by 1 minus 1 by 4 where close plus tan inverse 1 by 7. This is equal to tan inverse 1 divided by 3 by 4 plus tan inverse 1 by 7. This is equal to tan inverse 4 by 3 plus tan inverse 1 by 7. We know that tan inverse x plus tan inverse y equal to tan inverse x plus y divided by 1 minus xy. Therefore, we can write tan inverse x plus y, x is equal to 4 by 3 plus y is equal to 1 by 7 divided by 1 minus xy, 4 by 3 into 1 by 7. This is equal to tan inverse 21 plus 3 is equal to 21 minus 4. Tan inverse 21 can you cancel 21 plus 3 31 divided by 17. Tan inverse 31 divided by 17 is equal to right hand side. Hence proof left hand side equal to right hand side. Therefore, 2 tan inverse 1 by 2 plus tan inverse 1 by 7 equal to tan inverse 31 divided by 17. Next, we will discuss another question. Question number 5. Remember, these questions are very important for the board exam. Question number 5. Write the following functions in the simplest form. Tan inverse bracket root square root 1 plus x square by x minus 1 comma x not equal to 0. Tan inverse bracket root 1 plus x square minus 1 divided by x where x is not equal to 0. Solution. Let x equal to tan theta. Then we have tan inverse root one plus x is equal to tan theta. Therefore, 1 plus tan square theta divided by tan theta minus 1 bracket close. This equal to tan inverse. We know that 1 plus tan square theta from trigonometric formula we have 1 plus tan square theta equal to sec square theta. Therefore, this equal to sec square theta minus 1 divided by tan theta. Tan inverse root square root sec square theta is equal to sec theta minus 1 divided by tan theta. This equal to tan inverse bracket start, sec theta equal to 1 by cos theta minus 1 divided by tan theta is equal to sin theta by cos theta. From the trigonometric formula, tan theta equal to sin theta by cos theta and sec theta equal to 1 by cos theta. This equal to tan inverse cos theta 1 minus cos theta divided by sin theta by cos theta. This and this cancel. Therefore, tan inverse into 1 minus cos theta divided by sin theta. This equal to tan inverse 1 minus, we know that cos theta equal to, we can write 2 into theta by 2. Therefore, 1 minus 2 sin square theta by 2. In previous class, we have already discussed cos theta equal to 1 minus 2 sin square theta. Therefore, this equal to 1 minus 2 sin square theta by 2 divided by sin theta. Sin theta we can write sin 2 into theta by 2. Therefore, we know that sin 2 theta equal to sin theta cos theta by 2 sin theta by 2 into cos theta by 2. 2 sin theta by 2 into cos theta by 2. This equal to tan inverse 1 minus 1 plus 2 sin square theta 2 sin square theta by 2 divided by 2 sin theta by 2 into cos theta by 2. Bracket close. 2 to cancel, sin cancel, tan inverse sin theta by 2 divided by cos theta by 2. This equal to tan inverse tan theta by 2. This equal to theta by 2. 1 by theta is equal to 1 by, first let theta equal to tan theta. Therefore, x equal to tan theta. Therefore, theta equal to tan inverse x. Therefore, theta equal to tan inverse x. The simplest form of this function is equal to 1 by 2 into tan inverse x. Now, we will discuss another question. Question number 6. Question number 6. Write the simplest form tan inverse 1 by root 1 minus x square minus 1 bracket close modulus x greater than 1. Solution. Write the simplest form tan inverse 1 by root 1 x square minus 1 where modulus x greater than 1. Let x equal to sec theta. Let x equal to sec theta. Then we have tan inverse 1 by root sec square theta minus 1. This equal to tan inverse. We know that sec square theta minus 1 is equal to tan square theta. Root tan square theta is equal to tan theta. This equal to tan inverse is equal to 1 by tan theta is equal to cot theta. From the trigonometric formula, 1 by tan theta is equal to cot theta. This is equal to tan pi by 2 minus theta. Already we have learned tan pi by 2 minus theta equal to cot theta. Therefore, pi by 2 minus theta. Since tan inverse tan theta is equal to theta. From the properties of inverse union functions, tan inverse tan theta equal to theta. Therefore, tan inverse tan pi by 2 minus theta is equal to pi by 2 minus theta. This is equal to pi by 2 minus, here x equal to sec theta. Therefore, theta equal to sec inverse x. Therefore, theta equal to sec inverse x. This is the required answer. Tan inverse 1 by root x square minus 1 is equal to pi by 2 minus sec inverse x. Next, question number 7. Tan inverse bracket start root 1 minus cos x divided by 1 plus cos x bracket close x less than pi, where x less than pi. Here tan inverse bracket start root 1 minus cos x divided by 1 plus cos x, where x less than pi. Solution: tan inverse bracket start root 1 minus cos x. We know that cos x equal to 1 minus 2 sin square x by 2 or 2 cos square x by 2 minus 1. From the trigonometric formula, we have cos x equal to 1 minus 2 sin square x by 2 or cos x is equal to 2 cos square x by 2 minus 1. Therefore, we can write x equal to 1 minus 2 sin square x by 2 1 plus cos x is equal to 2 cos square x by 2 minus 1. This is equal to tan inverse bracket start square root 2 sin square x by 2 sin square x by 2 divided by 2 cos square x by 2 bracket close. Tan inverse root, we know that sin square x by 2 divided by cos square x by 2 equal to tan square x by 2 equal to tan square x by 2. This equal to tan inverse tan x by 2. This equal to x by 2. Since from the properties of inverse union functions, we have tan inverse tan x equal to x. Therefore, tan inverse tan x by 2 is equal to x by